In this video, you are going to learn about measures of center. Last week, we were describing data by drawing graphs. This week and next week, we are going to summarize or describe the data numerically. So let's suppose that you have a data set and you get one number with which to describe that data set. If you only get to pick a single number to summarize or describe the data set, you're going to want to use a measure of center. You're going to want to tell people where the center of that data is. There are 4 measures of center that we are going to be covering today. We're going to talk about the mean, the median, and the mode. You probably already know how to calculate these, but we're going to cover them again and go through them in review. We're also going to talk about the weighted mean, which is particularly useful for students because it shows up a lot in college and in school. In this video, you're going to learn how to calculate all these measures. We're going to do some examples and see when they apply. Any one of these measures could be referred to as an average. So the word average is not a technical term. It doesn't have a formula associated with it. It could refer to any of these 4 measures. So just be careful with the word average. The mean is found by taking the set of numbers you have. Suppose you have n numbers called an x1, x2, ... up to xn. Then to find the mean, you are going to take the sum of these numbers and divide by the number of numbers. We call the number of numbers n. The formula written out looks like this. We call that symbol at the beginning x bar, and that is the symbol for the sample mean. So this symbol right here is x bar. Again, it's read out loud as x bar, and it's the symbol for the sample mean. The symbol for the population mean is mu. It's a Greek letter, again, read out loud as mu. And the formula for population mean and sample mean are the same thing. So if instead of finding the sample mean, I wanted to find the population mean, I could say mu equals x1 plus x2 plus ... all the way up to xn divided by n. It's the same formula, whether you have a population or a sample. The median is the number such that half of the data set is larger than the median and half of the data set is smaller than the median. You find the median by first listing the numbers in your data set from least to greatest. We're going to let n be the sample size again. We're going to let n be the number of numbers. And if n is odd, then the median is the middle number in that list of numbers from least to greatest. If n is even, then you need to find the mean of the 2 middle numbers. And we're going to do some examples of finding the median shortly. There's not one agreed upon symbol for the median. There's several symbols, but one symbol that people sometimes use is a capital M. The mode is the value which occurs most frequently in the data set. If the data set has 2 values that tie for the most frequent, then both values are the mode, and we say the data set is bimodal. You can also have a multimodal data set. That's when you have more than 2 modes, 3 or more modes. We're not going to worry about that so much, but you can have a data set with multiple modes. If you graph the histogram for a data set with a class width of 1, or in Google Sheets, we say the bucket size is equal to 1, then the mode is visible on the histogram as the value that has the tallest bar. If the bucket size is not 1, then the mode may or may not be in the tallest bar. Often it is, but it's not guaranteed if you're not using a bucket size of 1. So when you're finding the mean, median, and mode, everyone always wants to know how they should round. The rounding guidelines are that you should round the mean and the median to 1 decimal place more than the original data. And we don't round the mode since the mode is necessarily one of the original data values. Let's look at an example. So we want to find the mean, median, and mode of this data set, 6, 5, 7, 4, 1, 7. So to find the mean, we are going to add up all the numbers, 6 plus 5 plus 7 plus 4 plus 1 plus 7, and divide by n, where n is the number of numbers. In this problem, n is 6. So we get 30 over 6, which equals 5. To find the median, we need to put these numbers in order. So we'll have 1, 4, 5, 6, 7, 7. When you do this, it's always a good idea to count and make sure you didn't miss any numbers. 1, 2, 3, 4, 5, 6. We have all 6 of our numbers. It's easy to lose numbers when you're copying them down. Now, because n is even, we need to take the 2 middle numbers and find their mean. There is not a single number in the middle of this list of numbers, so we need to find the mean of the 2 middle numbers. So the median equals 5 plus 6 divided by 2, 5.5. And the mode is the most frequently occurring number. It's 7 because there are 2 7s. Let's do another example. Find the mean, median, and mode of 6, 5, 7, 4, 1, 7, 4. So again, to find the mean, we're going to add up all the numbers, divide by the number of numbers. 6 plus 5 plus 7 plus 4 plus 1 plus 7 plus 4 divided by n here is equal to 7 because there's 7 numbers. So for this problem, we get 34 over 7, which equals 4.9 after we round. To find the median, we need to list the numbers in order. So 1, 4, 4, 1, 4, 4, 5, 6, 5, 6, 7, 7. And because the number of numbers, the sample size is odd, it's equal to 7, there is a number right in the middle. 5 is right in the middle, 3 numbers less than it, 3 numbers greater than it. So the median is 5. Finally, for the mode, there are 2 numbers which tie for the most frequent, meaning that this data set is bimodal, and the mode is 4 and 7, or the modes are 4 and 7. Also, it's now would be a good time to mention that it is possible to have a data set which does not have a mode. So another example might be if we had the data set 6, 5, 7, 4, 1, 2, 3. There is no number which occurs the most frequently here. They're all tied. There's only one of each of the numbers. So when we're looking for the mode in this data set, there is no mode. There's no mode. Measures of center and levels of measurement. So the three measures of center that we've talked about can be used with different types of data. The mode can be used with all types of data. It can be used with nominal, ordinal, interval, or ratio data. Whether you have a categorical variable or a numerical variable, you can always find the value which occurs the most frequently, unless there's no mode, but that doesn't depend on the data type. So again, the mode can be used with all types of data. The median can be used with ordinal, interval, and ratio data. Anything you can put in order, you can use the median with. Just a quick note, if you are finding the median of an even number of values of ordinal data, then it can get complicated. There are different methods to do this. We're not going to go through it. It's beyond the scope of this class. But if you have an odd number of values, then you can use ordinal data with no problems. Finally, the mean can only be used with interval and ratio data. The variable needs to be numeric in order to use the mean. So let's look at another example. Suppose that a pizzeria recorded the sizes of pizzas ordered, and we want to find the mean, median, and mode of the data. So here's the data: small, small, medium, medium, large, large, large. We cannot find the mean because this is ordinal data. You can't add up these words and find a total and then divide by the number of numbers. The median is medium. That's hard to say. So this data is already in order from smallest to largest. And the value that's right in the middle is the size medium. So that is the median. The mode is the value which occurs the most frequently. And there are 3 larges, so large is the mode. The next type of measure of center we're going to talk about is a weighted average. And suppose you have n numbers, x1, x2, up to xn, and each number has an associated weight. And we're going to call those weights w1, w2, up to wn. Then the weighted average is, you're going to take each weight and multiply it by the value that's associated with that weight. So x1 times w1, x2 times w2, so on and so forth, up to xn times wn. And then you're going to add up those products. Finally, you're going to divide by the sum of the weights. And we're going to go through an example right now. Weighted averages are used to calculate your GPA, and they're often used to find your semester average in any particular class. So for example, in a biology class, the semester average is weighted as follows. The midterm is 15%, the final exam is 35%, the homework is 20%, and the lab grade is 30%. If Crystal scores an 85 on the midterm, a 92 on the final, a 78 on the homework, and 100 in the lab, what is her semester average? So we're going to take each one of these weights and multiply them by the value associated with it. So midterm is 15%, and Crystal got an 85 on her midterm. So I'm going to turn 15% into a decimal, 0.15, and multiply that by 85. Then we move on to the final, whose weight is 35%. So we take that weight, 35%, multiply it by the value of the final, which was 92. Plus, take the weight for the homework, which is 20%, 0.2, times the value of the homework, 78. Plus, we take the lab grade, the weight for the lab grade, 0.3, and multiply that by the value of the lab grade, which is 100. Finally, we are going to divide by the sum of the weights. So we're going to add up 15% plus 35% plus 20% plus 30%. This works out to be, and you should give this a try and make sure you get the same answers as I do, 12.75 plus 32.2 plus 15.6 plus 30 divided by, and this adds up to 1, which makes sense because the grade needs to be 100%. And so we got 90.55%, which we'd probably round to a whole percentage, 91% in the class.